Hello 8th graders. In this IXL support video we're going to be taking a look at F10, which is called multiplication and division with exponents. I'm also going to go a little more quickly because this just combines F8, multiply with exponents, F9, divide with exponents, and makes you use both skills at once. So I'm going to move a little more quickly here. F8 and F9 go in more depth for those videos. First thing I'm going to do is recap our two key rules about multiplying and dividing with exponents. If we multiply with exponents, whenever you multiply with exponents, if it's the same base, all you need to do is add up those exponents. And when you divide with exponents, division being the opposite of multiplication, each exponent or each copy of the base in the bottom cancels one out on the top. So whenever you divide the same bases in a fraction, you can just do the numerator's exponent minus the denominator's exponent to find out how many copies of that base are left over. So we're going to go back to this problem, but again, we're just really using those two rules this whole time. So here for this first one, they tell us 837 to the power of 7 times the same base to the power of 6. So that's really just going to be, 7 plus 6. I'm not going to write this whole thing out here. I know I have the same base, 837, 7 copies times 6 more copies. Or in total, we have 13 copies of those 837s multiplied together. So keep the base the same, still 837 is the base, but if I multiplied 7 and 6 more, I have a total of 13 of those bases, or 13 of those 837 numbers multiplied together. I'm going to ask you at this point, if you're watching, just definitely pause the video, think about what's the correct answer here. We see the same base multiplied together, and hopefully you're saying, Mr. Doherty, all we got to do is add the 8 plus 9, and if I go ahead and add 8 plus 9, that's just going to get me to 17. And I'd say, yep, you're definitely correct on that. So our answer here is going to be 946 raised to the power of 17. And again, all this assignment will do is toggle between the multiplication rule and the division rule that you learned in F8 and F9. Here we have a division or a fraction problem. So if I recall, whenever I divide, each copy on the bottom cancels out one on the top, so I'm going to take the 6 copies on the top, subtract the 9 copies on the bottom, since they'll each cancel one out. And here, yep, there are more 203s on the bottom, so I'm going to get a negative exponent. That really means I'm going to have, let me hit enter here, 203 to the power of negative 3. When I do this, we see, oh, there were more copies on the bottom, we end up with a negative exponent, which really means, hey, there should have been, at the end of the day, 3 of the copies of 203 left over in the denominator, where we're going to divide by the 203 3 times. And since they wanted a positive exponent, I kind of got to go with this answer here, even though it's the same thing as 203 to the negative third. You see here, I'm kind of rushing a bit here, or moving quickly, and the same thing as a fraction is this slash symbol. And instead of hitting the fraction button, I just said 1 over 203 to the third. I think they're going to take that. And that's really all this assignment is. I will encourage you, if you're still watching with me right now, if you don't think you have F10 down fully, try to do this on your own. But hopefully you're saying, wait a minute, Mr. Doherty, same base divided, all I got to do is numerator minus denominator. And that tells me there's still 75 copies of the base, or 75 copies of the base term 375 left over for our final answer. Now, this one I was going to skip ahead, but this is fun. Feel free to pause the video, think about this one. We're multiplying with exponents. They do have negative exponents involved. But I'm just going to go ahead, pause the video. What do you think the answer is? And now when you're coming back with me, hopefully some of you are saying, hey, Mr. Doherty, we're multiplying the same base. All we need to do is take the top exponent and add the bottom exponent, 1 plus a negative 1. And in that case, it would get 0. So you'd say, that's a little weird, 392 to the power of 0. But ultimately, 392 to the power of 0 just equals 1. Now I know they say simplify, so I think they're going to mark 392 to the power of 0 wrong, because they think it should be simplified to say 1. And I'm curious, so I'm going to put in my answer, 392 to the power of 0, see if they mark me wrong or correct. Hey, they marked me correct, and they would have marked you correct, I believe, for either one of those answers. They both would have been correct. I thought this was more simplified. All right, I'm going to skip ahead a little bit. We think you're perfect shape for F10 to work on your own, and I'm going to jump into the more challenging ones around 72. And here's what they do in the 70s, 80s, and 90s on F10 to make it tougher. They just make you combine both rules at the same time. So if you see a fraction, a division problem, and it also has multiplication in either the numerator or denominator, the first thing I would do is simplify that expression. And by that I mean I would do the multiplication in the denominator first. I'm multiplying the same base down in the denominator so I could add those exponents. I know positive 1 plus negative 2 is going to give me a negative 1. So I know the denominator can simplify to 693 to the power of negative 1, and I got that by adding 1 plus negative 2. And now once I've done that, this is still a tough problem. I like IXL in this way. I have 693 to the power of 1, and I know I can subtract whatever's in the denominator. Our rule for division was subtract whatever's in the denominator. So I'm going to be doing 1 minus a negative 1 here. Because I take the top exponent and I subtract whatever exponent is in the bottom. And you may remember from last year, 1 minus a negative 1 really means the same thing as 1 plus 1. That's what it means to subtract a negative. So our exponent's actually going to become a 2 here. And there's a cool property of math we'll show you here. Some of us will get more comfortable with negative exponents and know if we pull that into the numerator, it becomes a positive exponent, and 1 plus 1 would have also given us 2 copies of 693. And they're going to continue to be difficult and mean on this, and I like that, but this gets rapidly more difficult on F10, I can tell. Once you're in the 70s and 80s, this becomes a lot more challenging. First thing I'm going to do again is I'm going to simplify, and by that I mean I'm going to go ahead and do 90 plus 47. The reason I'm doing that, 90 plus 47, is I see the same base multiplied in my denominator. And I know that gives me 137. So I'm going to go ahead and set this denominator up. Give me a second. But I know the exponent now for 849 at the bottom, its big exponent, is going to be 137 copies down there. That's 137, I'm sorry, it's hard to read. And on the top we have 86 copies of that. So I have at the top 849 raised to the power of 86. And now when we use our division rule, we're going to be doing the top exponent minus the bottom exponent. So I'm really going to have to do 86 minus 137. And I think of that as 137 minus 86, if we're being honest. I'm going to do 137 minus 86. 130 minus 80 gives me 50. There's one extra because 7's bigger than that. And I'm going to get a negative answer there because the larger absolute values, the negative one, are the one being subtracted. So as you see, this is a bunch of work, but it does tell me that my exponent there is going to be negative 51, or I'm going to get 849 to the power of negative 51. And I need to remember that that's the same thing as saying 1 divided by 849 to the power of 51. And all they're really telling us in this very complicated problem is there were 51 more copies of 849 on the bottom than the top, and that's why we end up dividing by those 51 copies. But as you can see, this does get challenging for F10 in the 70s, 80s, and 90s, and I'm also happy to work with you all on that. Here, you would just be adding up all these exponents because it's multiplication, but the video is pretty long at 9 minutes. So I will say two things. Number one, once you get towards the 70s and 80s, it's a lot more difficult here. Number two, if you're in the 70s and 80s and my video doesn't help a ton, you still need some practice. Remember, I'm ddoherty3 for an email at bostonpublicschools.org. And I'm always happy to chat with you about some of these more challenging problems for IXL towards the end. Thanks for working hard on the challenging assignment, and keep up the great work.